All right, if at all possible for these notes, you want to have graph paper, definitely. So if you don't have any of your own, go to the website. I'll put some up for you there. If you don't have a printer, I'm sorry in advance. Try to get your hands on some graph paper if you can. Okay, so the title of these notes is Graphing Sine and Cosine Functions by Hand. So first we're going to go ahead and look at the transformations, because once we know the transformations, then we can graph them. So y equals a times sine of bx plus c plus d. Okay, so the number in the front, actually I'm going to make that go further away because I have lots to write. Okay, so this number in the front tells you what the amplitude is. And so we know from the past, because we've already learned about this, that the amplitude is actually kind of like a vertical stretch or compression. So it's like how tall or not tall, how tall or short the graph is going to be. And so we know from previous experience that if A is greater than 1, it's a stretch. If A is less than 1, the absolute value of A, it's greater than 1, is less than 1, it's a compression. And we know that if there's a negative sign in the front, then it was reflected over the x-axis. So the different numbers mean the same thing that they've meant before, but instead of calling it a vertical stretch or a compression, we call it the amplitude. Okay? It's gonna put me, sorry, my arrow looked dumb. Okay. For the rest of this, when we see something written like this, we have to factor it just like before. So I'm going to factor out the b, and that would leave me with x plus whatever c divided by that b value is. Okay, and sometimes they'll give you the problem written like that and sometimes not. So just watch out for it. The b value is the period of the graph, which is how long it takes for the graph to start in one place and do a cycle of its rotations and then kind of get back to where it started. Okay, so just like before when we learned about horizontal stretch and compression, the numbers kind of mean the same thing. So if we have a b value that's greater than 1, it's a compression, because it's the opposite of what we would think. If we have a b value that is less than 1, that means it's a stretch. Right? And here we're not going to talk about reflecting over the y-axis because the graphs are like symmetric on either side, and so it's kind of silly to do that, so we don't typically do that. Okay, so typically we're only going to have stretches and compressions, but instead of calling them horizontal stretches and compressions, we're going to say, oh, the period of the graph changed. Right? The way that you calculate the period of the graph is you take 2 pi and you divide it by the b value. Okay, so that's how you calculate that. You might circle that or highlight that or put a star next to it or something, because that's a formula that you're going to have to memorize. It's just a very simple formula. All right, just like normal, this tells you how far to the left or the right you go. If it's positive, you go to the left. If it's negative, you go to the right. The number on the end tells you how far up or down you go. If it's positive, you go up. If it's negative, you go down. Okay? All right, so just a little bit more detail on amplitude. Amplitude is how far the graph goes from the midline. All right, a normal amplitude is 1. Okay, so over here I'm going to write normal amp is 1. So from the middle of the graph, if it goes up 1 and down 1, that's normal. Okay, we would say there's no amplitude change. Okay, the period of the graph, like I said, is how long it takes to do a full cycle. And so a normal period for the graph is 2 pi. And that's because that's how big a circle is. So that's how much it takes you to go around the unit circle. Okay. So what I want you guys to do whenever you graph these, this is a little note. This is not like something that's mathematical, that it's like an agreement, everybody has to do this, but this is something that I want specifically. So I always want you to graph at least 5 points for one period. Of the curve. And then copy those 5 points for a second period of the curve. And the reason that I have you do that, and the reason that a lot of math teachers have their students do that, is that these graphs are cyclic, which means they go up and down, up and down, up and down, up and down, up and down forever. And so we ask you guys to do 2 periods of the curve so that you can show us that you understand the pattern, that you understand that once it goes past what you have found, it's going to keep going and doing the same thing. Okay? All right, so let's go ahead and do a couple example problems. So the first one we're going to do is we're going to graph y equals 3 times sine of 2x. All right, so in this problem, 3 is the amplitude, and this is a positive value, and so that means that it has not been reflected over the x-axis. So it has an amplitude of 3. And that means from the midline, it's going to go up 3 and down 3. So total, it's going to have a height of 6. Okay? And then based off of this, we can go ahead and calculate what the period of the graph would be. And it would be 2 pi, hold on, let me write period. It'd be 2 pi divided by b, which is 2 pi divided by 2, and that's just pi. Okay? All right. So we're going to go ahead and sketch this graph. My assumption as I'm going through these notes is that this is not the first time you've ever graphed these. So if that is the case, then I'll go ahead and have you write something off to the side of this problem. So a normal sine graph starts at 0 and ends at 2 pi. So a normal sine graph starts at 0, goes up to +1, and then hits 0 at pi, and then it goes down to -1, and then it hits 0 again. That's a normal sine curve, okay? And we're going to use that idea as we draw this graph. All right, so what I typically do is once I figure out what the period is and what I figure out what the amplitude is, then I do the labels on my graph. And so I'm just going to make sure that this goes up to 3 and down to -3 because that's what my amplitude says. And then the period of my graph is pi, and I like to do my boxes in sets of 4 because it makes it a lot easier to draw. So I'm going to count 1, 2, 3, 4, and write pi. And then 1, 2, 3, 4, and put 2 pi. Okay. So what I like to have you guys do is figure out what the middles of things should be, okay? So what I'm going to do with my red marker is I'm going to label the midline. And the midline on this graph is right here at 0. And we should go up here to our notes because I forgot to have you mention it up here. But the number on the end tells you what the midline is. Okay, and that's the middle of the graph. So the reason that I knew my midline was 0 is because this equation didn't have anything after it, so it would just be +0. And so that's why I drew my midline there. All right, if the graph has not shifted to the right or to the left at all, then you're just going to start at 0. So this graph, it just looks like I'm being a little bit extra and drawing my axes in red. which is fine. We can be extra. Okay, so what I'm going to do is I'm going to say I need to follow this pattern, but instead of bouncing up and down between 1 and -1, I'm going to bounce up and down between 3 and -3. And instead of having a width from 0 to 2 pi, I'm going to have a width from 0 to pi because that's what the period of my graph is, okay? So I'm going to keep this pattern, but I'm going to use these numbers instead. So I'm going to start here, just like they started right there at the beginning, and then I'm going to end over here. So instead of ending at 2 pi, I'm going to end at just pi because the period of my graph has changed. I know it hits 0 in the middle. And then I know between these 2 points it bumped up to 1, so I'm going to bump up to 3 between those first 2 points. And between the second 2 points it bumped down to -1, so I'm going to bump down to -3. And there's my graph. And I'm making sure that these are nice U-shaped graphs and not V-shaped graphs because these are nice smooth curves. So what I'm going to do next is I'm just going to go ahead and continue that pattern. And you know that you did it right if you can just trace the graph with your finger and your finger goes up and down, and it's kind of like a rhythm, okay? If you're tracing it with your finger and your finger kind of stutters, it means that you made a mistake somewhere. All right, so there is our first example. Let's go ahead and try another one. In each example, we're going to make the transformations a little bit more difficult so you can see how that makes our job of graphing them a little bit more difficult. Okay, so the next one that we're going to go ahead and draw is going to be y equals, I guess I had a cos graph next, y equals -2 cos of pi thirds x. All right, so you can see in this one that I have some extra parentheses, and really it's just like the last example. It's just like this one. This one had less parentheses. It's kind of like they're thinking about it in factored form for you a little bit, where it has like an extra parentheses between the number that's a coefficient for x and the x itself. It's kind of like they want you to see like, oh, this is pi thirds and this would be x plus 0. So you guys can see it's not moving left or right. Okay, so I have a negative in the front, so that means that this graph is going to be reflected over the x-axis. My lead broke, so let me get some more lead. So reflected over x. The 2 means that there is a vertical stretch of 2. This is going to be twice as tall as normal. But in these graphs, we don't call it vertical stretch, so that means there's an amplitude of 2. And then this transformation is going to tell me that the period of the graph has changed. So what I'm going to do is I'm going to do 2 pi divided by the b value, which is pi thirds. And this one requires a little bit of math to figure out what the actual period of the graph should be. So I'm going to do keep it, change it, flip it. So 2 pi, change to multiplication, flip 3 over pi. And so the pi's will cancel, and that just equals 6. So the period of the graph is 6. Okay, and then on the end we would have had a plus 0, and so that means that 0 is the midline. All right. So just like before, we do have like a basic version of a cos graph, and that's kind of what helps us draw our graphs when we do them. So if you have not seen this, or if you don't remember it, go ahead and draw this sketch of a cos graph. Again, it goes from -1 to 1, and it goes from 0 to 2 pi. So cos graphs normally start up at 1, and they end up at 1 at the end. In the very middle, they go down to -1. All right, so in between these 2 points, they have to cross 0, and in between those 2 points, they have to cross 0. Now that looks like a V graph, but it's not. These are nice smooth curves. So I make sure that when I draw this, I draw it like a curved graph. So I'm drawing it with U shapes instead of making a V shape. So that's what a cos graph should look like. Okay, so now I have to draw my axes so that they make sense for the numbers that I have. So I have to make sure that I have room to go up and down by 2, and I have to make sure that I can draw a period of 6. I drew that way too high. And like I said, I like to do sets of 4 boxes. The reason that I do 4 is because we're going to divide the picture in half, and then we divide it in half again. So if I had to draw a period of 6, I might do like 12 boxes, because 4 boxes and 8 boxes don't go into 6 very well, but 12 does. So I'm going to go ahead and count 1, 2, 3, 4, 5, 6. So I'm using 12 boxes. And then with my amplitude of 2, I want 2 and negative 2. So I'm going to go ahead and use my marker, and I'm going to trace. That's not negative 2, that's negative 3. Okay, so I'm going to go ahead with my marker, and I'm going to trace my midline. And since my graph has not been shifted left or right, I'm going to go ahead and trace this. Okay. And then I'm going to make sure that I can draw this cos graph. So instead of starting up at 1 and ending up at 1, I have to start at 2, but it's been reflected over the x-axis. So instead of starting up, I'm going to start down. So I begin at negative 2, and I end at negative 2. Okay, so it starts up, it ends up, it hits negative 1 in the middle. But we're reflected, so right in the middle we're going to hit positive 2. And then, like I said before, between those we have to cross at 0. So between these we cross at 0. Between these we cross at 0. I already kind of broke my rule because I said you have to draw 2 periods of the graph, and I did not leave room for that. Let's see if we can, how many more of these we can draw. Not enough for 2 periods. Sorry guys, didn't mean to be a bad example. Okay, so there's like a period and a half of the graph. And again, if I trace it with my finger, it's just smooth curve, up, down, up, down, up, down. Okay, so next I want to go ahead and do an example that's a little bit more difficult so you guys can see what would happen if we start to shift the graph up and down or left and right. And so that was example 2. Here's our third example. So our equation for this one is y equals sine of 3x minus pi over 2 plus 1. All right, so in this one, I need to factor this part out. So I'm going to say that's y equals sine, and I have to take out the 3. So if I take out the 3, that leaves me with just x. And for this part, I have to think of pi halves being divided by 3. So if you have pi halves and you divide it by 3, you actually get pi over 6. And the reason for that is we think of this as a 3 over 1, and we would do keep it, change it, flip it. So pi over 2 times 1 over 3 is pi over 6. Okay, so pi over 6. So here there's no number in the front, so that tells me I have an amplitude of 1. This 3 tells me that I have a period of 2 pi divided by 3, so 2 pi thirds. My graph is going to shift to the right, pi over 6, and it has shifted up 1, which means that my midline is 1. So this graph is a lot more exciting because there's more going on. Okay, so we're going to go ahead and figure out how we need to graph this. Okay, So I know that the period of the graph is 2 pi thirds, but I have to be able to shift it to the right and left pi 6. So I want to make sure that I can, that I'm able to do that. So I don't want my graph to be too small. Like if I chose for one box to be pi thirds and 2 boxes to be 2 pi thirds, then graphing right and left pi 6 would be kind of hard. So we can kind of go with the idea of 4 boxes for this one or 8 boxes for this one because it's going to not be too big either way. So I'd say let's go ahead and just do 4 boxes. That's not too bad. So 2 pi thirds, and then 1, 2, 3, 4 would be another 2 pi thirds. That would be 4 pi thirds. All right. So if you want to do the in between, if that's 2 pi thirds, this would be pi thirds in between. In between 2 pi thirds and 4 pi thirds would be 3 pi thirds, which is just pi. Okay, and then up and down we have an amplitude of 1, and we're eventually going to shift the whole graph up 1. So I'm going to say maybe go to 2. Okay, so with my midline, instead of, I'm not going to draw it at 0 like I did on the other ones, I'm going to draw it at 1. Okay, and then the whole graph has to shift to the right pi over 6, and based on my graph that's 1 box, and so I'm going to shift to the right 1 box. Okay, so now what I'm going to do is I'm going to graph a sine graph, and I'm going to pretend that the red are my axes. All right, and that's all I have to do, and it will have all those transformations in it. So let's remember what a sine graph looks like. So a sine graph normally starts at 0, ends at 0, hits 0 in the middle, goes up to 1, goes down to -1. Okay, so our graph, and we have to remember how many boxes this was. It was 4 boxes, okay? That was the full period of the graph was 4 boxes. So I'm going to start at 0, I'm going to end at 0, which was 4 boxes. I'm going to hit 0 in the middle, okay? So start at 0, end at 0, hit 0 in the middle. We have an amplitude of 1, so between the first 2 points, I'm going to go up 1. Between the first 2 points, I go up 1. Between the second 2 points, I go down 1. All right? And then I go ahead and continue the pattern after that. Now, if it bothers you to have that extra marker in there, because it just feels kind of random, you're welcome to do like the rest of this in pen and then do that part in pencil, because then you can erase it. But this way we can do all of the transformations all at one time without having to do it as 2 different parts of the same process. So I know that's not a lot of examples. We'll definitely do some more in class to make sure that you guys feel like you can do these.